Welcome back, everyone. I'm John Furrier, host of theCUBE, here in our New York Stock Exchange studios with Dave Vellante. We're kicking off our AI Factory series, where we talk to the leaders who are making the game-changing decisions and technology that's enabling this next wave of generational change that's going to create new software layers, new ways to engage, of course, changing society. And with Climate Week going up here in New York, a lot of big data technology innovators making a lot of technology to help solve a lot of the problems. Dion Harris, Senior Director of HPC and AI Infrastructure Solutions with NVIDIA is here, the company that is leading the change. Actually, love the AI Factory. I think Jensen Huang said that 2 GTCs ago, maybe earlier. Dion, thanks for coming on theCUBE. Really appreciate it.
Thanks for having me. Pleasure to be here.
So I just got to say, when Jensen said AI Factory, I love that term. And then Dell picked it up.
Yeah.
And they're using it. So he's very much sharing the name. And it's kind of a very good concept. But it really kind of speaks to what's in it. Data, all kinds of elements. Sure. We're seeing the data center be a computer. That's one trend. Data centers together being a bigger computer. Sure. Scale across that you guys talk about. So you start to see the system game change in the old school data center and even in the hyperscalers. So even the recent news of NVIDIA putting $100 billion into OpenAI, which has a huge application. Sure. Running a lot of NVIDIA because it goes fast. Yes. You're starting to see that AI native software paradigm come in. And that's not just GPUs. Sure. It's software. I mean, I go back 15 years. Jensen, we're a software company. Right. Of course you are. There's a lot more going on. Yeah. And liquid cooling is one. We're going to talk a little bit about that. Sure. But this changed high-performance computing from the old workstation days. Where's the compute, go faster, inch by inch, and then a few years ago, it just really started to accelerate.
Yeah. So just to talk a little bit about, like you said, that shift that's happening from classic data centers to AI factories. And more than a physical shift, it's actually a mental shift. And what I mean by that is really understanding that these AI factories are revenue centers now. They're not just cost centers that are just driving efficiency gains and productivity gains. They're actually driving revenue. And so when you think about a factory, it produces output. In this case, an AI factory, the output is tokens. And these tokens are used to, synthesize new drugs. They're used to, discover new materials. They're used to create, all sorts of innovative large language models that have different applications. And so understanding that sort of philosophical shift of the underlying technology is really a factory for intelligence, which are expressed through tokens.
Yeah. And the other thing that's going on, I want to get your thoughts on, is that NVIDIA is very clear. Here's our roadmap on the supply side, supply chain side. The processor is very transparent. But now you have an ecosystem developing on the other side. I call it a two-sided market for NVIDIA, which is the enterprise. Okay? If you go back 10 years ago, there wasn't a lot of ecosystem action. You had gaming, GeForce is well known, Bitcoin has picked it up. But now the integration of these large-scale systems is really changing the entire landscape, specifically the enterprise. Yeah. Not just high-performance computing market. Sure. But the enterprise.
Yeah. So just speaking broadly about ecosystem, I'll just touch on that for a second. We recognize that in order to really build these solutions, deliver them to the entire market, NVIDIA couldn't do it alone, right? And so we really need to make sure that we invest heavily in making sure that the entire ecosystem is ready and prepared for the solutions that we're building so that they can build the infrastructure that it takes to run those applications. In terms of how it's making its way into the enterprise, you recognize that, again, a lot of enterprises like Procter & Gamble, a lot of enterprises like Nike, their core competency is understanding their customers and their markets. So we want to make sure that as we build solutions that take AI to the market, we want to make it as easy and seamless as possible for them to adopt AI. So that's why we've invented things like NIMs, which are about taking containerized models and making them simple and easy to deploy on the infrastructure. So trying to stratify and simplify as much as possible so that as you roll these into enterprise AI applications, they're seamless. But then you also have to make sure that the security is there, that and it can fit all the data profiles for the enterprise. And so we've invested a lot in safeguards and guardrails within the AI model building and development process that helps ensure that, when these models are deployed, they meet the overall governance and sort of security requirements of a lot of the enterprises as well.
One of the things that I notice is that people love AI. One, they love NVIDIA stock, so congratulations. Mainstream retail people are buying the stock. But as the Gen Zs come in too, they actually don't really understand what a data center is. Now, old school folks do. Sure. But you look at the transformation of the data center, You say, okay, I can see how AI is close to the data, go on premises, that's clear. But then you hear Jensen at GTC say, KV Cache is the operating system for the AI factory. Okay, let's put a pause there a second. So that's networking, right? Okay, so what that means is there's a lot going on under the cover. So let's unpack what's that system. KV Cache, liquid cooling. There's a lot of elements and system elements that make the data center like feel and act like a supercomputing. It's not like a magic wand. I mean, take us through the importance of that, because there's a lot of design involved. There's a lot of long game kind of thinking.
Sure. Well, when you think about concepts like the data center or the cloud, great abstract concepts, but they all run on the hardware. There's networking, there's compute, and there's storage, right? And so when you think about AI, there's really kind of two main operations that you're trying to do. There's training and developing the model, and there's inference. When you get to the inference, which is essentially how you extract the value out of AI in terms of using it and deploying it in applications, the key thing about inference is when you understand to deploy it at scale efficiently, you need to make sure you can understand not just the type of model you're running, but obviously the profile of it, like, when do the model needs to be available, how are the user access patterns affecting the demand on the infrastructure, but then also on a per user basis, you need to make sure that when the person goes to issue their query, the response comes back in a reasonable time frame. And then you need to do that not for one user, but millions of users. And so that's why when Jensen described our Dynamo software, it's really a software package that orchestrates across all the layers of the infrastructure, across the compute, the networking, and the storage. And in order to do that, you have to have just general awareness, right? And understanding, okay, where this query came in, where does the data exist in terms of being able to service that and generate tokens to support that. But then you also need to understand, okay, how long should I keep it in memory versus move it to storage? And how do I make sure that that transfer of data is seamless? And so that's really, like I said, when you think about NVIDIA, we build GPUs and we build networking, but the software that orchestrates that user experience is really what creates the value. And that's why when we describe a lot of these X factors in terms of performance improvements from generation to generation, some of it lies in the hardware and the die and chip design. Some of it lies in the actual networking element, but a big portion also resides in the software that helps all these systems run faster and more efficiently.
And I think it's notable, obviously we know this, that NVIDIA and OpenAI have a relationship. Their advantage as an application is directly a result of the software. CUDA and other software they're running. So they get a competitive advantage. I want to take that to kind of like verticals. So as a CUBE, we were covering tech. We know we love infrastructure, so we can cover that all day long. From 3 in the morning to whatever, we'll talk about AI infrastructure.
I'm here for it.
But you're seeing AI now go mainstream. It's in every vertical. Retail's an AI show now, NRF. You got life sciences, the discoveries that are happening with the AI factories. You're starting to see an enablement there. This week, Climate Week is here as part of the UN, and the streets are pretty much closed in New York, as you found out with the taxis. Climate we cover from a sustainability standpoint because the data center is a sustainability conversation.
Absolutely.
Sure. But there's also an emergent factor of entrepreneurs working on large-scale problems that were ungettable 5 years ago because they have data, they can store the data, they can crunch the data, they can actually use NVIDIA to do that because it's available. So you're starting to see like tech nerds doing really hard problems. Figure out.
Shout out to the tech nerds,
Let's index the entire grid of the atmosphere. Like what? So take me through what you're seeing there, because you're looking at these solutions. You're seeing that this pop up where this market's starting to develop. Why and how and what are some of the things that you're seeing on the progression of the new way?
Right. So first of all, at NVIDIA, we truly believe that if a problem isn't hard, we don't want to expend resources on it. We'll let someone else tackle it. And there's no greater problem or challenge than being able to understand, simulate, predict, and model our environment, right? Because things are constantly changing. There's so many, sort of physical properties to manage and predict. And so when we look at sort of our core portfolio of technologies, we thought this is a great opportunity to kind of bring those technologies to bear. So we talk about accelerated computing and just being able to simulate and model a lot of the first principles-based dynamics that goes into understanding the climate and the environment. We talk about AI, which is another new technique which is used to create emulation models that can accelerate and actually make that whole prediction process much more seamless, much more available and sort of efficient in terms of being able to really understand those different dynamics. And then third, we have our digital twin technology, which is about how do you represent complex systems? How do you bring all these different data types together, whether it's observed data through satellites or it's sensor data or it's simulation data? How do you bring all those into one complex system that you can then model and use as a visualization technique that also is being used to share and collaborate across those data sets? And so we have this effort called Earth 2, which is really about taking those core foundational technologies and enabling the tech ecosystem, those tech nerds you talked about, to really harness the power of AI, harness the power of digital twins.
Earth 2 for us, because I think, so is it a center,
a
compute center, or they have to go procure massive amounts of...
So Earth 2 is really sort of a platform shift, and we basically, like I said, let's take these core technologies that we've developed and have been working on for a number of years now and expose them to the broader tech ecosystem. And so we do that not just by creating products and selling them, but actually developing AI surrogate models. So we had a model called FourCastNet that we just released called that really does AI surrogate modeling for weather forecasting. We had another model that's called CorrDiff, which takes output data, super resolves it so that you can get much more localized, sort of interpretations of that data set. Then we also have another model called Climate-in-a-Bottle, which takes not just forecast data, which is weather, but also looks at climate scale data and does that same sort of hyper resolution, super resolution, which makes the data much more actionable for a fraction of the cost.
So scientists, companies,
absolutely,
entrepreneurs.
And when you think about the impacts of weather, it's one of those things that goes unnoticed, but every time you take a plane, right?
Yeah.
You need to understand weather patterns and how it's going to be affecting that plane route. Every time you ship a package, you need to understand, what's happening in the oceanic atmosphere. Every time you're doing any sort of shipping and logistics, disaster recovery, agriculture, like whenever you're understanding how your overall weather conditions are going to be for a given season, that dictates which crops are going to be successful. So we're here at the New York Stock Exchange. That obviously has significant effects on the commodities market. So weather is one of those things that is so ubiquitous and wide-reaching in terms of the impact. We saw it as a huge problem that we could contribute these technologies to help drive some efficiency.
And that was what I was saying about the instrumentation of data. It's there, but it's not attainable. Right now it is. So talk about the model, because at GTC I was very fascinated by the physical AI story with NVIDIA, because the thesis was, hey, the physical world's connecting with digital.
Sure.
We're seeing that play out in financial institutions with crypto and blockchain. Old and new are coming together as one first-party set of data.
Sure.
The other thing is that you guys were showing that you have a lot of synthetic data and you're making the data smarter, but you're offering it up.
Yes.
This is what Earth 2 is doing. Is that right? So you guys are adding value and saying, hey, we've done some stuff. Put more data in, real data or synthetic data?
So Earth 2 is one instantiation of that, where we're basically creating these different technology platforms, and we're working across the entire global ecosystem with ECMWF, with NOAA. We've been doing a lot of work with the weather channel and weather company, So it's really recognizing that this problem by definition is a global scale problem. So going back to the initial point we talked about in terms of ecosystem, we're trying to bring that entire climate tech ecosystem together to build solutions on that platform that can then sort of advance it. And so making a lot of the data available, like you mentioned, making the models available and open and accessible is a lot of the core functions of Earth 2. But when you talk about sort of getting into the physical AI challenge, right? That's where, like I said, as we've been talking about AI, most of what we've been describing has been virtual AI, whether it's chatbots, whether it's, sort of virtual implementations of AI. But as AI goes into the physical world, it's what we call a three-computer problem, meaning that you have to train the AI to understand and build a model of just the general world itself. But then you also have to create a training ground where AI can learn how to interact with the physical environment, learning things like gravity, learning things like object permanence, right? All these elements that you learn through interacting with the world, you have to teach the physical AI to do that. And then once you deploy it, there's some edge device, there's some humanoid robot, there's some self-driving car, there's some autonomous, medical device arm. Those elements are the other part where AI gets implemented physically. And so that's where we're seeing a ton of opportunity there as well.
Dion, one of the hottest content series we have is AI infrastructure, AI, which is AI Factories now. Here at the NYSE Wired program that we do. The other one is robotics. Robotics is getting a shot in the arm, literally, with AI, because now that's a true opportunity to put high performance compute either in the robot, whether it's manufacturing or humanoid, and talk to a bigger cloud or a bigger data center in real time. This was demoed, and you guys are very bullish on this as we are.
Yes.
We love robotics. We think with open source and synthetic data and simulation, the acceleration for solutions is going to be faster. So the question is, as you're in charge of HPC, high performance computing, which is like supercomputing, that's inside the industry, but also AI solutions. As these new solutions come out, what are you seeing as the progression? Is there a pattern around the innovation? Is it a use case that they pick up? Do I have to go all in end to end? I interviewed a company that's working with NVIDIA that has an autonomous vehicle, L4 from the ground up. NVIDIA's powering the whole thing, one of your chips. It doesn't even talk to the internet. It's basically a rolling AI factory. So you're starting to see, it's not an obvious pattern, but what are you seeing? Because you have to look at the solutions. I'm sure there's headroom that I'm not seeing.
Well, what I'll say is I think there's massive connectivity between these different approaches and markets that we're looking at in terms of going from virtual to physical AI. And let me just sort of tease this out a little bit. You talk about self-driving cars. First, you need to build the model, and that happens in a data center, right? You need to basically help your computer understand the rules of the road, how to interact with certain types of, obstructions. And that's all a part of just training the core foundational knowledge. Then you need to help simulate that to do it millions of times, right? Because a lot of what you want to do is make sure that you can give it an environment so that it can learn without having to learn on the road, right? We have lots of regulations that prohibit you from doing that. And that's why we have a platform called Omniverse, which is solely around having virtual worlds that allow you to create these training grounds. And we actually open sourced our Cosmos platform, which basically makes that available to a number of different developers in that ecosystem to help train and develop those digital models for physical AI. And then, like you said, the endpoint, which is the car, like building a self-contained system that can have all the redundancy, have all the safety requirements, have all the performance required to execute all these models and all this learning that it's been trained on. That's where NVIDIA really shines, because we're able to take sort of our core data center, sort of skill set and apply it to the model building, the world building, and then the actual last mile inference in the real time.
We could do an hour just on that solution.
For sure.
It's so fast, and and you guys are making it so much faster. Huge fan. Everyone kind of knows that. I want to get into something that we talked about before we came on camera. You have a background in the grid, energy, and then also software has been a key component for NVIDIA. So sustainability, software knobs to manage sustainability. Is there a way to kind of manage that on the fly with like maybe some AI? But also the energy side's bounding the problem. So power, interconnect, your systems are built. You got InfiniBand here, you got scale up, scale out, now scale across. Different use cases, but together they work as the system. Talk about the power component and specifically the grid. Is there going to be work there? How do you see that happening? And then how do I manage my sustainability equation?
Well, it's interesting when you talk about AI, it represents both, sort of a challenge and an opportunity. A challenge in that requires a lot of energy as we're building out the data centers, and you think about all the growth that's being projected in terms of CapEx spend around the data center, and therefore all the power required to support that. That's the challenge. But the opportunity, in fact, there was a recent report that we published earlier this week by CSIS. Sorry, I mispronounced that. But CSIS will help us really understand how our different energy sort of generation and utility grid transmission and management organizations going to harness the power of AI to help be a part of the solution. And so when you think about what happens and actually I spent 5 years at the regulated utility in the California, it's called PG&E, and you recognize that there's significant challenges in terms of, one, bringing new load to the grid. And there's a reason why that is, because you have to make sure that you can maintain the reliability and the security of the grid, so you want to be somewhat cautious. But in the absence of having data and tools to help, simulate data better, to help model it in a more sophisticated way that gives you more granularity to ensure that you can ramp production on and off for data centers while bringing that load on, but also maintaining that reliability. So there's a ton of solutions that are being brought to bear. There's a company called Utilidata that we've been working with that instruments, smart meters, that instruments the transformers themselves to really understand at a granular level the load so that you can more granularly monitor and manage that overall network performance. There's also companies like Emerald AI, which is looking at how do you manage the efficiency of the data center itself in terms of getting power in and out. And so we've been very sort of hands-on and working with that broader ecosystem, not just of what's happening in the data center, but we call it sort of from chip to grid, not just looking at the chips, but looking at how it impacts the downstream, sort of power and cooling within the data center, but also in terms of managing and operating the grid itself.
Well, it's really good you guys have that software, because at the UN Climate Week, the big conversation is, the future of the planet, obviously.
That's right, yeah.
Data centers are a big part of it, but AI can help too, right? So again, It's AI for the planet for AI kind of thing going on. So congratulations on that. I'm glad you guys are doing what you're doing. I guess my final question for you is, okay, what are you optimizing for? You have your job is to put AI solutions out there. That's what everyone wants.
Sure.
High performance computing, to me, that's just the data center. That's AI factories, check. AI factories is good. I like that direction. But a lot of people are really wanting to intersect with this. What's your goals? Share some of your objectives for the next year. What do you hope to accomplish?
Well, we have a very ambitious vision for what AI can deliver. In order to do that, we have things that we can control that we need to really, deliver on, which is all the products that we're bringing to market, all the, incredible innovation we're doing at the core chip level, at the networking level that we talked about, being able to, use our scale-up rack architecture like NVLink, scale across and using Spectrum-X and our other capabilities there. So we have a very ambitious roadmap that, we have to execute on. So that's sort of first and foremost. And we think in doing that, it'll deliver more performance, more efficiency for your power-constrained data centers, and that will help, sort of ease that burden. But then the other responsibility I think that we feel as being sort of the stewards of this sort of AI movement is making sure the entire ecosystem is ready and making sure that we're engaging with not just the data center builders and designers, but also all of the MEP partners who are building mechanical, electrical, and plumbing solutions to outfit it, to make sure that as we, create our new hyper-dense, megawatt scale rack architectures, that their bus bars are ready, that their power whips can support the power density, that their CDUs are have the proper pipe diameter to support all the fluids that's required to cool a lot of these systems. And so understanding that we have a unique perspective in that we see the models that are coming. We're working with all the advanced model developers like OpenAI and Mistral and others. And we also understand the products, obviously we're building them. So that gives us a unique advantage to help drive a lot of those downstream requirements. And so I think that's really, sort of our core objective, is to make sure that the entire ecosystem is ready, and therefore we can do it in the most responsible and efficient way possible.
Awesome. I do want to touch on one more thing, if you don't mind.
Sure.
Because we didn't get to the liquid cooling conversation. Something that you're close to.
Sure.
Very important piece of this.
Yes.
Is the power and the cooling.
Yes.
Just quick highlight on liquid cooling and the importance of it. What's the state of the art for the NVIDIA? What's in it for the customers? How are they using it? What's the design criteria, requirements? So
I always like to start out by just first describing like what's happening with the application. So first we understand what's happening with AI models. Particularly, we've always known that large training projects require lots of data center scale systems. But what we're also seeing is now inference workloads are no longer run on a single GPU or a single server even. You have multi-server, multi-rack deployments of inference. So to the extent that we can get these compute engines to talk to each other better, drives more performance and efficiency. So if you start with that as sort of the key requirement, we look at our architecture and start with a clean sheet of paper saying, okay, what do we need to do? So first thing, we need to stay on copper as long as possible, because you lose less energy when you convert from copper or electrical to optical. And so that's where our scale-up rack architecture comes into play. And so we have to call it NVLink, which allows you to scale to over 72 GPUs today and beyond. And so that is a requirement. And then the next downstream effect of that is how are you going to cool it, right? So having a compute density, so typically data centers we're optimizing on 20 kilowatt racks, whereas our current Blackwell architecture is anywhere from 120 to 130 kilowatts in a single rack. If you're going to drive that compute density, liquid cooling becomes really important, right? And so that's the way we think about it is first, what does the application require? How can you really meet the requirements and the needs to serve that application efficiently? And then what does that mean for our architecture? And then as a result of that, we've landed on direct liquid cooling as being a key technology to enable that. And that's why we're working with all of the major, sort of CDU builders and providers like Vertiv, like Schneider Electric, CoolIT, Cooler Master, you name it, because we recognize that that core of technology needs to be there in order to deliver the performance and the efficiency that we're trying to get to.
And Dion, what's great is that the solutions and the AI native applications are coming out fast. You guys are enabling that. So again, keep working at it.
Yes.
And we love what you guys do. Love the company. Again, watching the success of NVIDIA is like watching the changing of the guard in the computing industry.
Yeah.
Because the enablement is massive.
Sure.
So again, all verticals, all industries, not just apps and tech.
Yeah.
All industries.
It's been a fun ride. And like I said, I often say that, NVIDIA has been like a 25-year overnight success in the sense that, with the advent of CUDA in 2006, that had no obvious value, but being able to understand that general purpose computing would be a thing for GPUs, and now seeing all the different use cases. Gaming was the first. It extended into a lot of the scientific applications. AI was 2012, and now we kind of see this.
Multiplication applies to all now neural networks. Again, This is a beautiful thing because that's called the long game.
Exactly.
So you guys have played a lot. This video is actually circulating. I just saw some great videos of Jensen going back years and years ago.
Yes.
A lot younger. And it actually got the same message. It hasn't really changed.
It hasn't changed one bit. I mean, it all started with the advent of accelerated computing, putting, a GPU with a CPU, and it was recognizing that parallel programming was going to be the way forward for all types of applications, whether it was going to be scientific applications, whether it's going to be database processing. AI came along and became a killer app. Video processing is an obvious one. So we really approach each domain in the same approach. We basically say, let's look and see how can we add value to developers by giving them software and solutions that make it easy for them to adopt accelerated computing. And then once you find a developer community that really sees value in it, that drives the growth.
And I think the AI factory and the physical AI vision and mission aligns with that too. It's not like it's a special version for retail.
Exactly.
Data's data.
Yeah,
you can't have an AI factory without a data factory.
Yes. And so, I think that's one of the things, like I said, the fact that we have such a fungible platform that can be used to serve databases, can be used to run AI, can be used to, simulate CFD simulations. And that really lies in our software. All the work that we've invested in our CUDA acceleration libraries, that is really sort of the magic of the platform. In other words, you can't just hand someone a GPU and a network connection and say, go run your quantum circuit simulation.
It's software. Software is awesome with AI.
That's it.
Yeah, thank you for coming on.
Thank you so much.
We got another hour. NVIDIA here inside theCUBE. Again, the physical AI factory equation is bringing the physical and digital worlds together. Tokens are output of the factory. Software gets smarter, faster, cheaper to write, spend more money, make more money. Jensen's Law, we love that. Of course, we're doing our part. I'm John Furrier with Dave Vellante here at our NYSE studios, part of the NYSE Wired community, and of course theCUBE. Thanks for watching.